All right, now that we've covered properties of logarithms, we can solve some more sophisticated logarithmic equations using those properties, okay? So here I'm asked to solve the equation 4 log base 2 of x subtracted by log base 2 of 5 equals log base 2 of 125. And what I'm noticing here is that the left side of this equation, it has two logarithms to it, all right? Recall we had a logarithmic property of equality that said something like this. It said if log base a of m equals log base a of n, then that means m equals n, right? You can only use that property when it's a single logarithm equal to a single logarithm and they have the same base. So in this equation that we've been presented with, that's not the case right now. All right, I have two logarithms on the left side. Well, the good thing is I can use my properties of logs to condense that left side down, okay? So I'm going to start by bringing 4 up as a power on x. Okay. And then the fact that those two logarithms on the left side have subtraction between them, I can use a quotient property and rewrite this as log base 2 of x to the 4th over 5 equals log base 2 of 125. Now, notice it's a single logarithm equal to a single logarithm, so I can effectively ignore the logarithms, set the arguments equal to each other, and solve for x. So I'm going to multiply both sides by 5 there. It's going to take me to x to the 4th power equals 625. And then you could just take the 4th root of both sides, and you'll end up with positive 25 or negative 25. But recall, when you plug any of these numbers back into your equation, if they make any of the logarithms have an argument that is negative, that logarithm would be undefined, okay? So that means this negative 25 actually has to be thrown out. And we can only keep the positive 25 for our solution, okay? All right, next example. Solve log base 8 of x added with log base 8 of x minus 12 equals 2. All right, so two things to notice here. The first is that the left side of the equation has two logarithms to it, okay? And then the second thing to notice is that the right side of the equation has no logarithm to it, all right? So that's going to change our overall approach to solving this equation, okay? But we want to start with the left side, and we want to try to condense that left side down. Since those logarithms have the same base and they're being added together, you can use a product property, and you can multiply the arguments of x and x minus 12 together. Okay, so of course that's going to lead me to log base 8 of x squared minus 12x equals 2. All right, now once again, notice there is no logarithm on the right side of this equation, so I can't just simply set x squared minus 12x equal to 2. All right, there is no property that says I can do that. Instead, I need to go to exponential form. I need to take the base of 8, raise it to the 2nd power, and then equal that to the argument. All right, so 64 is equal to x squared minus 12x. Let's get it set equal to 0 here. Okay, and then that is factorable. X minus 16, x plus 4. So x will equal 16 or negative 4. Now once again, just like on the previous example, if either of those solutions make any of the original logarithms in the equation have a negative argument, then you need to throw them out. So this negative 4 is extraneous, and you're just left with 16 as your solution. Okay. All right. Try the next two problems yourself, and then come back and check your work with mine.